Let's look at integration by substitution with limits. So the example says, using the substitution u squared equals 4x plus 1, work out the integral from 6 to 20 of 8x over the square root of 4x plus 1 with respect to x. So the first thing is that this integral is in terms of the variable x, and so we first need to change these limits to obtain limits in terms of u. So we're going to substitute these values into this equation. For x equals 6, we end up with u squared equals 4 times 6 plus 1, and so we get u squared equals 25, so u equals the square root of 25, which is 5. And for x equals 20, we end up with u squared equals 4 times 20 plus 1, which is u squared equals 80 plus 1, which is 81, and so the square root of 81 gives us u equals 9. Now, to use our substitution, we need to change from integrating with respect to x to integrating with respect to u. So we're going to have to differentiate both sides of this equation with respect to x. So we have u squared equals 4x plus 1, and now differentiating the left side with respect to x, we're going to use implicit differentiation. And so differentiating u squared gives us 2u, and then if we differentiate the inner function u, we get du over dx, as we're differentiating with respect to x. And now on the right hand side, 4x differentiates to 4 with respect to x, and 1 differentiates to 0 with respect to x. And so making dx the subject, if we multiply both sides by dx, we end up with 2u times du equals 4 times dx, and now dividing both sides by 4 gives us a half u times du equals dx. We look at the function we're trying to integrate, we can see the numerator is 8x. We can obtain 8x in terms of u using our substitution by rearranging. So starting with u squared equals 4x plus 1, we take away 1 from both sides, we end up with u squared minus 1 equals 4x. And now if we multiply both sides by 2, we end up with 2 times u squared minus 1 equals 8x, and so we now have the numerator which is written in terms of u. Likewise, to obtain an expression in terms of u for the denominator, we can square root both sides of the substitution given. So we have u squared equals 4x plus 1, and square rooting both sides gives us u equals to the square root of 4x plus 1, which is equal to the denominator. And so therefore the integral from x equals 6 to x equals 20 of 8x over the square root of 4x plus 1 integrated with respect to x can be written as the integral. So the lower limit for when x equals 6 gave us u equals 5. The upper limit when x equals 20 gave us u equals 9. And now we saw that 8x can be written as 2 times in brackets u squared minus 1. This is all over the denominator, which can be written as u. And finally, dx can be replaced with a half u times du. So multiplying by a half u times du. So at this stage, we're dividing by u and multiplying by u, so we can cancel this. We're also timesing by 2 and timesing by a half, which cancel. And so we're now left with the integral from u equals 5 to u equals 9 of u squared minus 1 integrating with respect to u. So if we now integrate this expression, to integrate u squared, we add 1 to the power, so it becomes u to the power of 3, and then we divide by this power, which gives us a third. And then to integrate minus 1, that becomes minus u, and now our limits are equal to 9 and 5. And so at this stage, if we substitute our limits in, we have a third multiplied by 9 to the power of 3 minus 9, and all of this is then subtracted by when we substitute 5 into the expression. So we have a third times 5 cubed minus 5 all in brackets. So this now becomes 9 to the power of 3, which is 729, times a third, which is 729 over 3 minus 9. And then all of this is subtracted by 5 cubed, which is 125 over 3 minus 5. And so if we expand the brackets out, we end up with 729 over 3 minus 9, and then minus 125 over 3 minus 5, which is plus 5. And so if we simplify this further, we get 729 over 3 minus 125 over 3, which gives us 604 over 3. Then we have minus 9 plus 5, which is minus 4. So we can now write this as 604 over 3, and minus 4 can be written as minus 12 over 3. And so therefore, if we take away these two fractions, we end up with 592 over 3, which is the final answer to this question.